Hello everyone, my name is Enrique Potter and I am going to be your teaching assistant for CS 1550. In this video, we are going to go over some basic commands, some basic programs, and some basic routines that we're going to be using all over this course. And hopefully it will make your life easier as the semester progresses. So, in CS 1550, we are going to introduce you to operating systems, or as you might see more often, OS. If you have a computing device with a CPU and memory that allows you to execute multiple applications, possesses different peripherals for I/Os such as touch screens, mouses, and displays, you will need to solve the problem of efficiently sharing these resources between the running applications, and that is the role of an operating system. So you probably heard about the iOS and the Android that runs on your smartphone. However, there is a plethora of other operating systems, and all of them are solving similar issues. Most of the systems are based on Linux and thus have similar design, with similar commands and naming conventions. So if you get experience with one Linux-based system such as Ubuntu, and understand what are the problems that an OS needs to solve, you will have a good grasp and understanding of most existing operating systems. Now let's talk about projects. Every project must execute in our server. You can first make sure that it executes in your own machine, but later make sure that it can execute in our server as well, since we're going to use our environment uh, to equally grade everyone. So please make sure that the project runs in our servers as well. One of the servers is tot.cs.pit.edu. To connect to our servers, you're going to need a SSH client. If you have a Windows machine, you can use PuTTY, and if you have a macOS or Ubuntu machine, you should use the terminal. So for Windows, you can download PuTTY at putty.org, and once you execute the application, you're going to see a screen similar to this one, and you should enter the address of the server below the host name uh, label. Also, make sure that your connection type is selected to SSH, and then finally you can click open to start the connection. After that, you're going to see a black screen such as this, where you should first enter your PIT ID and then your PIT password. And if everything goes okay, you should be connected to one of our servers. If you have macOS or Ubuntu, you will need to use the terminal. To open the terminal, you go to Applications, Utilities, and click Terminal. Once that opens, you should see a screen that is similar to this one. Then, to use the built-in SSH client, which usually should already be installed, you can just write SSH, the address of the server, and you should connect. So for example, you can write your PIT ID first, then the name of the server, and finally the port number. If everything goes okay, it should ask for your password. Once you enter your password, you should connect to the server. Okay, so now let's go over some basic Linux commands. Now, you probably already know these commands, but the idea here is just to refresh, since you're probably going to need them in your first project, and we'll be using them in all the future projects. So one of the very common commands that we're going to use is the pwd, which stands for print working directory. As you can see here, when you call pwd, it will show the name of your current directory. Now, this is very important because when you execute any program, it will use the current working directory to search for files, unless you will specify the full path of whatever file your program needs to consume. Another common command is the ls. It allows you to see all the files and directories of your current working directory. So in this small example here, you just write ls and it will print all the directories and files of your current working directory. Another two common commands is the commands to create and delete directories. So for example, if you want to create a directory, you can just write mkdir and the name of the directory, and it will create that new directory. Then to remove it, you do the same. You just write rmdir, the same name again, and it will remove the directory. Also, to remove files, you can just write rm. So here, for example, we have a file called sometext.txt. You can just write rm, the name of the file, and then that file will be removed. Other important command is the cp, which stands for copy. So if you want to copy one file to another directory, you just write cp, the name of the file you want to copy, and the destination path. As you can see here, we copy the file name sometext to the directory this desktop. Then if we go to that directory, you just write ls and you will see the file you copied. Other command that we'll be using quite often is the mv, which stands for move, and it will simply move files from one place to another. And the idea is pretty much similar to all the other commands. We just write mv, the current path of the file you want to move, and its new path. So for example, you can move the file sometext.txt to the desktop folder, which will move it instead of just copying it. Environment variables allow you to save text information that can then later be used by any program running on that operating system. The following commands allow you to create, list, and remove environment variables. So now I will show you a small example of how to use environment variables. So with the command env, we can list all the current environment variables. Usually, both Windows and Linux-based systems come with some default variables. To print the specific value of a specific environment variable, we can use the command print-env and then just write the name of the variable you want to see. When you press enter, you will see the value of only that variable. However, if you want to create a variable, you can use the command export, write the name of the variable, and give it a value. When you list the environment variables again, that newly created variable should be there. Then to remove it, you can just use the command unset. And then that variable should no longer be there. When you're writing a program in C, you can easily compile it by just calling the compiler, the file containing your code, and then name the output object. However, when you're writing bigger programs, it's a good idea to divide your code into many files. And that's when the makefile comes handy. So to illustrate, let's say that you want to compile a program called calculator, and then this program is going to depend on these two files. So main.c depends on this header, while sum.c will depend on this other header as well. All these files, once compiled, will create these two objects, main.o and sum.o, which will then be used to create the calculator program. So how would you write this makefile? So first you define the name calculator and its two objects, and then below it you just define the command that will be executed. Then below it you define how that main.o that you defined above is going to be compiled and its dependent files. And then further below it we define how the sum.o is going to be compiled and the command that is going to be executed to do so. As you can see, there is a dependency here, so main.o is being defined here, while sum.o is also being defined down below. If we plug everything together, we can see that sum will unify all the objects by calling that command, and both of those objects are going to be then further defined as well. Then you can just call the program make, and then the first tag that we defined it called calculator. Now if you noticed, you can see that that calculator is the very same name that we defined right here. And then when you call that, you will just run all the commands that we defined in the make file. Another very good practice is to define another command or routine called clean. So in this clean routine, I will just call the command to delete all the files of my current working directory that ends with the extension .o. Then we can just call that routine by writing make clean, and that will just execute the command to delete all the files that ends with the extension .o. Another very useful program that I recommend everyone to use is a GUI-based FTP client. Now that will allow you to easily move files in and out of any server that you connect by SSH. So a program that I recommend to both Windows and macOS users is the FileZilla. You can easily download FileZilla from the web. Once you install it and execute it, you should see a window that is similar to this one. Then if you click that little icon there in the corner, it will pop up this window which allows you to create multiple different sites that will save your ID and password to allow you to easily connect whenever you want. So here you can see that I chose the protocol SSH. You can see also the server name, the port, and my logon type, user, and password. You should select the same options. Once you enter your PTID and password, you can just click connect. And that's all that I want to cover in this video. My goal here was just to refresh your mind of some basic Linux commands and to tell you and give some tips about which programs to use. So PuTTY will allow you to easily connect to SSH servers, while FileZilla can make your life easier when you are copying programs in and out of your own PC. If you have any doubts, you can email me or just show in my office hours.